Today we are going to see about scattering of light. We all know that due to the particles in the atmosphere, the sunlight usually we call it as white light, gets scattered. And there is a relation connecting the wavelength and the amount of scattering, which is given by Rayleigh's formula, or we call it as Rayleigh's scattering. The amount of scattering is inversely proportional to lambda power 4. That means if lambda decreases, scattering increases. So we all know that with GR. So violet is roughly 400 nanometer and red is 700 nanometer. So violet, the lower order 400 nanometers, the scattering will be more because this wavelength is less. Whereas in the case of red, it is 700 nanometer. This lambda has increased, therefore scattering decreases. So we can say that shorter wavelength scattered more than longer wavelength. So what is shorter wavelength? Usually it is violet. Longer wavelength is red, which is around 700 nanometer. Blue scatters strongly than red. Why? Because blue is shorter wavelength compared to red. Our eyes are sensitive to blue than violet. See, even though violet is wavelength wise, wavelength of violet is less than blue, we are able to see the sky as blue just because our eyes are sensitive to blue rather than violet. Why? Because if you watch carefully the visual human eye response to visual spectrum, violet amplitude is very much less compared to the blue. Therefore, we see the sky as blue, not as violet. Okay? Right. Next point. Scatterer. The particles, the water particles in the atmosphere, let the size of the particle be A. If that size of the scatterer A is very much less than lambda, we can apply Rayleigh's scattering formula directly. Suppose if the particle size is very big or the scatterer size is very big, that is very much greater than lambda, all wavelengths are scattered nearly equal. That means whether it is violet or red, all the wavelengths are scattered equally. Therefore, when these wavelengths are combined together, we get white. So we can say that thus clouds which have droplets of water with A very much greater than lambda. That means the cloud size which is having a droplets of water, so the size A is very much greater than lambda, are generally white because all the colors are combined together to produce white. Now we have at sunset or sunrise, the sun rays have to pass through a larger distance in the atmosphere. Most of the blue and other shorter wavelengths are removed by scattering. The least scattered light reaches our eyes. Therefore, the sun looks reddish. That means this is the actual picture. When you see it near the horizon during the sunrise or sunsets, the distance traveled by the light through the atmosphere and to the observer, this distance is greater than during noon. This distance is shorter. So in this case, what happens is we see only the larger wavelength. That is, the sun looks reddish. So 700 nanometer wavelength is easily observed by the observer. All other lower wavelengths are filtered out. Whereas during the noon, what happens is the sky is very clear. We see the blue wavelength. So this is what happens because of the distance the light travels through the atmosphere. Here it is very short, here it is more. So as a general case, we can say the lower wavelength with GR, the lower lengths are removed during when the sun rises in the east and it sets in the west, because it has to travel a great distance. Therefore, the sun appears to be reddish in color during sunrise or during sunset. Whereas during noon, it has to travel very short distance, so we see the sky as blue. So that's all about this topic on scattering of light. Okay, scattering of light, and we have introduced some important formula which is Rayleigh scattering. So the amount of scattering is inversely proportional to lambda power 4, this we have said. So in terms of wavelength, if the wavelength decreases, scattering increases. That is one point we have to remember. And we have discussed about particle size. If the atmospheric water particle size A is very much greater than lambda, we can apply Rayleigh scattering. Or if the particle size is very much greater than lambda, then all wavelengths are scattered nearly equal. Therefore, it appears to be white. So that's all about this topic on scattering of light. Hope you have understood this topic. Thanks for watching. Nandri.